Hi juniors, Miss Elba here. I'm going to help you review for your upcoming unit circle exam. So we're going to look at just a couple different types of problems, everything that we've covered so far this unit. So first we're going to look at just converting angles and radians to degrees and vice versa. So the first, for number one, we're looking at converting the following to radians. So we're given angles in degrees, we need to convert them. So we have to remember that to convert from an angle to a degree, we multiply by pi over 180. It's a little bigger here. And when we do that, we would get 120 pi over 180 because, remember, the degrees cancel out and we're left with radians. So we look at this and we say, okay, well, can we simplify this? Well, sure. Right away I see they could both be divided by 10, so I could have 12 over 18. And then, well, they're both divisible by 6, so I can simplify again. 2 pi over 3, and that's radians. So if you want, pause the video, try the next two, and then I'll take you through the work. So I hope you got the same answer I did for the second one. That was for 405 degrees turned into 9 pi over 4 radians. For the last one, even though it's negatives, the principles are the same. So we would then multiply by pi over 180. Of course, my degrees cancel out. And we simplify that down to negative 7 pi over 6 radians. So these should be pretty straightforward. This was from the very beginning of the unit. So now we're just going to look at doing the same process in reverse. So we're going to convert the following into degrees. So right now we're given something in radians and we're going to change it into degrees. The process is very similar. I'm going to actually rewrite these to make multiplication a little easier. So this says 5 pi over 6. So 5 pi over 6 in radians. I would multiply that by 180 over pi. Then what happens is my pi's can cancel out. 5 times 180 gives me 900 over 6. And now we're in degrees because that's what was left from the 180 degrees. And so let's see, I can simplify this. 900 does divide by 6, so this is 150 degrees. Again, you can pause the video and try B and C by yourselves. For the second one, you should get 120 degrees. And then let's look at the third one. The third one is pi over 2. Now, you might intuitively remember where pi over 2 is on the unit circle, so that might tell you right away what pi over 2 is in degrees. But if you don't remember, you can, of course, still do the same process. So pi over 2 times 180 degrees over pi equals 180 over 2, or 90 degrees. All right. So next up is the unit circle. I'm going to have you try to pause the video and fill in a blank unit circle on your own. There is one linked in the directions for today's assignment. But before you begin, I was just going to give you a few tips to remember before you do this, right? So first and foremost, when you're doing the unit circle, you remember that we have 360 degrees in a circle, and you're going to go counterclockwise as you fill in the angles. So that's important to remember. Mr. Suhar gave you a nice little tool to remember the spacing between the angles. Remember your 30, 15, 15, 30. Say that over and over as you go around and you fill in the key angles you're going to use with the unit circle. Okay, second tip. Remember, if you can fill in degrees, you can convert to radians and simplify just by doing what we did up here. Okay, so for number 1, that's what you were doing. So once you fill in degrees, you can convert degrees to radians, and then be sure to simplify. Okay, third tip. Remember, as you're trying to set up the coordinate points, if you remember back to that video, every coordinate point is going to use some combination of the following 3. 1/2, square root of 2 over 2, and square root of 3 over 2. Okay, and we know that of these, the 1/2 is the smallest, right? The shortest, the smallest value. The square root of 2 over 2 is the middle value, and the largest one you have is the square root of 3 over 2. So that would be your longest lengths, your longest sides. All right, and fourth, just remember, you know your quadrants, right? So when you're going around the circle, remember we start in quadrant 1, which is always positive, positive when you look at your ordered pairs. Let's see, in quadrant 2, you'd have negative, positive, right? So your XY is negative and then positive. In quadrant 3, they're always negative, negative for your ordered pair. And in quadrant 4, they're always positive, negative. Okay. So it just helps to remember that as you go around and fill this in. So what I'd ask is that you pause the video here and take a moment to try your hand at filling out the unit circle. Like I said, it is linked in the directions for today's assignment. You can see one below here on the screen as well. I'll just leave that up for a moment. All right, I hope you had some luck filling out the unit circle. I'm going to now pop up a finished unit circle so you can take a look and see how you did. Hopefully you have a pretty good understanding of how the unit circle works at this point, and you're able to find whatever you haven't memorized easily, knowing how the unit circle works a little better now. Okay, so my last questions we're going to do are just right here. We're given a list of angles, either in radians or degrees, and we are just going to find the cosine and the sine of each, as well as I want you to list what quadrant they're in. So you can draw this little table in your notes. When you look at the top, we have cosine and sine. I want you to see if you can remember which is which. When we are looking for cosine or sine, what are we looking for? If you're thinking of the ordered pair, then you're in good shape. Cosine is always your x value, and the sine is going to be your y value for the given angles. So for number 1, let's take a look here. We have 17 pi over 3. So when you go back up to your unit circle, of course, you might right away notice that 17 pi over 3 is not listed on here. So you either need to figure out everything with the denominator of 3, which we could take a look. Let's take a look. We have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 as we go around. So I am looking, let me just give you some lines here. Here, 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 and here. Okay, so when you figure out the pattern of how these are laid out around the unit circle, you can keep counting around to get up to 17 pi over 3. That is what Mr. Suhar showed you in the video from last week, Thursday. Now, another thing you can do if you wanted to is you can think, well, to go once around a circle, you know, is 2 pi. So if you think about it that way, okay, if you have 17 pi over 3, I'm going to just write up at the top here, 17 pi over 3. And to go once around would be 2 pi. If you think about 2 pi, and I wanted to change that to have the same denominator as the 3, right? I could say that it's 6 pi over 3. Sorry, that should be an equal sign. There we go. 2 pi is the same as 6 pi over 3. So if you wanted to think of it that way, 17 pi over 3 minus 6 pi over 3, that's like saying we're going once around the circle and seeing where we're at. That gives us, what, 11 pi over 3. We could subtract 6 pi over 3 again. And we would be at 5 pi over 3. Which, of course, that should look a little more familiar, right? We have a 5 pi over 3 in what quadrant? Quadrant 4. Okay, so in the fourth quadrant. And then what is our cosine and our sine? Our cosine, we said, is going to be the x value. So the x value here is 1/2. And the y value is negative square root of 3 over 2. All right. Let's look at the next one. The next one is negative 660 degrees. So it's given in degrees. This angle is given in degrees. We could do the same thing, right? You can go backwards 660 degrees, which we know is more than a full rotation around the circle. So you could say negative 660. We can add 360. And what do we add? We're at negative 300. From there, if we added 360 again, what are we at? We're at 60 degrees. So I know that's where I need to look. Again, if you would like to just count backwards around the circle, that is, of course, totally fine. But I'm going to go up to 60 degrees here. And let's see. I have a cosine in which position? The x position. So cosine of 1/2, positive 1/2, and sine of square root of 3 over 2. And then we have to answer what quadrant was that in. So negative 660 degrees comes out to be the equivalent of 60 degrees in the positive direction. So that is quadrant 1. All right, so let's look at the next one. Next one is negative 29 pi over 6. So same thing. You can just start figuring out the pattern and counting it back. If you want to see how I added a full rotation in radians, I can do that again as well. So if I have, I'm going to write below the table here. So I have negative 29 pi over 6, which would mean that I have to take that 2 pi. Remember, once around is 2 pi. Don't want to forget that. Okay, so if I want to take 2 pi and put that over a denominator of 6, I'm going to add 12 pi over 6, which gives me negative 17 pi over 6. So I could add 12 pi over 6 again. It gets me to negative, back that up. Negative 5 pi over 6. All right, well, negative 5 pi over 6. 5 pi over 6, let's take a look at this up here, is right here in the second quadrant, right? This is 5 pi over 6. So if I know that 5 pi over 6 is part of the unit circle and I'm at negative 5 pi over 6, that's an easy one because I could just start at the 0 line and go the other way. So instead of going counterclockwise, we're now going clockwise because it's negative. So we end up here. This would be negative 5 pi over 6. Okay, so let's see what quadrant and our cosine sine. Quadrant, we are now in quadrant 3. My cosine is my x, that's negative square root 3 over 2. And my sine is negative 1/2. Okay, that looks pretty good. Let me go through and erase some of the marks on the unit circle I've made here. Okay, and then let's look at the next one. We have 150 degrees. Okay, well, this one's not negative, so this time we get to go forwards. Makes it a little easier. Let's see. Let's pop up here. Find 150 degrees. All right, well, what quadrant are we in? Quadrant 2. What's my cosine and my sine? Cosine is my x value, negative square root of 3 over 2. And my sine is my y, which is positive 1/2. All right. And then we have one final angle to look at. And this one is asking us to look at angle 360 degrees. Well, 360 degrees, where is that? 360 degrees, you should know by now, is one complete rotation. So we're over here. So what is our cosine and our sine? Our ordered pair for this point, right, would be 1, 0. So my cosine is 1. My sine is 0. And what quadrant I am? You're not in a quadrant, right? We are actually on the x-axis. Okay, so that's going to be everything, every type of problem you're going to see on the exam. I hope that helped. If you have any questions, of course, feel free to reach out, and good luck with your studying and your review today.